particles on a string is 10 centimeters. I equals to pi square f square a square rho into v. Delta phi 1 is 45 degrees. Delta phi 2 is 60 degrees. Phase difference is 2 pi by lambda path difference. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Remember my previous session? We started working out problems from the chapter Waves. Just by analytical comparison between the given wave equation and the standard equation, we arrived at the results. What do I have in today's session? We will be solving problems on the concepts of phase difference, path difference, and intensity of a wave. The first one, the distance between two particles on a string is 10 centimeters. Distance between two particles on a string is 10 centimeters. Find the phase difference between these particles. Phase difference has to be calculated. If the frequency of the wave is 400 Hertz and speed is 100 meter per second, distance between two particles on a string, I call that path difference. Distance between two particles on a string, path difference, delta x is 10 centimeter. So 10 into 10 power minus 2 meter. 10 centimeter alididrinda. Frequency of the wave is given. Frequency is 400 Hertz. Speed of the wave is given 100 meter per second. I have to calculate the phase difference. Do I know the expression for phase difference, students? Very much yes. Where we say phase difference is equal to 2 pi by lambda into path difference. Remember this expression. Phase difference is 2 pi by lambda path difference. I know the path difference. Do I know lambda? No, which means I have to calculate using the given parameters. So, we know that V equals F lambda. Wave velocity V is F lambda, or lambda is V by F. So V is 100, F is 400. So this is 1 by 4 or 0.25 meter. Substituting here, phase delta phi equals 2 pi 0.25 into path difference 10 into 10 power minus 2. On simplification, this turns out to be 144 degrees. Very simple. Just know these bit of relations. Very easily we can solve. Next one. Sound waves of frequency 256 Hertz. So frequency is given to be 256 Hertz. Amplitude 10 power minus 6 meter is produced in air. So sound waves with frequency 256 Hertz, amplitude 10 power minus 6 meter is produced in air. Calculate the intensity of sound. We are asked to calculate the intensity of sound provided velocity of sound in air is 332 meter per second and density is 1.29 kg per meter cube. Now we have a direct, well-defined expression for intensity where we told 2 pi square f square a square rho into v. So very clearly intensity of a wave is given by the expression I equals to pi square f square a square rho into v. Or on substitution, 2 into 1/4 whole square 256 whole square. Amplitude is 10 power minus 6. Rho 1.296 into 332. Pick up your calculators. Simple is the calculation. So 5.53 into 10 power minus 4 watt per meter square. So watt per meter square is the SI unit here. The next one. A sinusoidal wave propagating through air has a frequency of 200 Hertz. Now the frequency of the wave is given, which is 200 Hertz. If the wave speed is 300 meter per second, 300 meter per second, how far apart are the 2 points in the medium with the phase difference 45 degrees and 60 degrees? So phase difference kottidare illi. Delta phi 1 is 45 degrees. Delta phi 2 is 60 degrees. I have to calculate the path difference here. So therefore, now if I go to the relation, it becomes the inverse of what we did before. So, path difference is lambda by 2 pi phase difference. Alva? See, phase difference was 2 pi by lambda times path difference. So what is path difference? Lambda by 2 pi phase difference. Again, phase difference gottu. I have to calculate lambda, where again lambda is V equals F lambda. So V by F, that is 300 by 200. So it turns out to be 5 meters. First case, delta x1 is lambda by 2 pi delta phi 1, delta x2 2 pi phi 2, or delta x2 lambda by 2 pi delta phi 2 phi 1. I'm just subtracting distance between these 2 points. This is 1.5, 3.14, 60 degrees minus 45 degrees, which is 15 degrees. So 0.062 meters will be the answer. This is the path difference or the distance between the 2 points. A progressive wave is described by this equation: y equals 1.2 sine pi 2t by 5 minus x by 4, where x and y are in meters and t in seconds. Find the amplitude, wavelength, period and speed of the wave. You may take it as an assignment, just a comparison. First, I transform this equation into the standard form. Y equals 1.2 sine 2 pi t by 5 minus x by 2 has to be multiplied and divided. So 8. Now it is of the form a sine 2 pi t by t x by lambda. So amplitude is 1.2 meter. Time period, if you compare, is 5 seconds. Frequency is 1 by 5. So 1 by 5 is the frequency, so many hertz, and wavelength is 8 meters. With this, V is F lambda. Just substitute, you arrive at V. Again, with very simple expressions, students. Today I have solved problems on phase difference, intensity and path difference. Next, I come up with problems on Doppler effect. Until then, have a nice time. Thank you.